How's everyone doing? Everybody excited for Universal Studios tonight?
Yes.
Yeah, that'd be fun. All right, so welcome to a deep dive session on Microsoft Sync Fundamentals. My name is Andre. I'm a program manager on the OneDrive Sync client team.
I'm Andy. I've spoken to a good portion of you this week at the OneDrive booth, and I'm an engineer on the Sync client team.
Hi, I'm Adam. I'm also an engineer on the Sync client team, and I've spoken to a bunch of you as well.
Yeah, so in this session, we'll give you guys a high-level overview of how Sync client works, what are some of the fundamental principles behind OneDrive Sync, as well as we'll go into some high-level scenarios that you might encounter when running Sync client in your organizations. So before we dive in, it's really important to understand what are some of the fundamental principles behind Sync. So first and foremost, cloud is the master. So this is really the most important principle. What we mean by that is that cloud owns the data model, cloud owns the files and the file contents, and also cloud owns the file properties. And file properties are really names of files, who the files are shared with, etc. What this really means is that the cloud always has the most accurate representation of the files and their states. And the Sync client merely maintains the local snapshot of the cloud's data model. And whenever it detects local changes, it submits those changes for approval by the cloud. And only after the cloud approves those changes does the Sync client update its local data model. So the next principle is prevention of data loss is paramount. So ensuring data integrity and data security at every point in Sync is of the utmost importance. So this applies to both file contents and file metadata. And we've designed our Sync client closely with the service to ensure that this principle holds true during every point in Sync. Next is our focus is on efficient and reliable transfer. Our goal with this is really to do the required work to get your files in Sync as fast as possible and really just simply get out of the user's way after that. And finally, file content and file properties can be transferred independently. Our goal with this is to ensure that file property updates, such as file renames or file moves, are instantaneous. And the primary example of that is files on demand. So whenever you decide to sync down a OneDrive library or a team site, all of your files will be visible almost instantaneously in your Explorer or Finder windows. So now let's talk a little bit about what is going to happen when you add a file to your OneDrive directory on your device. So when you first add a file to your OneDrive directory on device A, one of the OneDrive Sync client components detects a local change and determines that a new file needs to be uploaded to the cloud in order for that device to be in sync. So it proceeds to start the upload, so it uploads the binary content of the file as well as the file metadata. And when the cloud receives the file and successfully persists it, it notifies the client that that was the case. So the Sync client updates its state, and now it's in sync with the cloud. At the same time, another device, let's call it device B, receives a notification from the cloud that something has changed. So it proceeds to ask the cloud what really has changed. So it determines that there's a new cloud. So there's a new file in the cloud that needs to be downloaded. So it initiates a file downloads, saves the file, and then updates its sync state to now indicate that it has a sync relationship with the cloud, and everything is in sync. So this is a really high-level overview of how Sync works end-to-end. So now let's talk a little bit about file transfer, specifically about file uploads and downloads. So our goal is really on creating an efficient and fast file transfer pipeline. And we're always working on optimizing file transfers to make them faster and more efficient while being mindful of your network. Some of the things that we've brought to actually optimize file transfers is last year we brought files on demand to Windows 10 PCs. And it really helps us to reduce the amount of bandwidth taken up by Sync, because only the files that the user chooses to work on locally actually generate upload and download activity. And now we're bringing exact same capabilities to Mac. Next is streaming. So streaming is the new functionality that we brought to the clients, and it applies to both the upload paths and the download paths. And it allows us to utilize the network resources a lot more efficiently, and also allows us to reduce the number of round trips between the client and the service, which ultimately leads to faster transfer times and reduced upload and download times. And based on our benchmark testing, we're seeing up to 2x improvements in download and upload speeds as a result of this. And also to better utilize available bandwidth on the device when uploading or downloading multiple files at the same time, we utilize parallel transfer technology that allows us to spread the workload across multiple threads. So while one thread is working on uploading a large file, the other thread can zip by and upload a small file at blazing fast speeds. So if you'd like to learn more how to better manage bandwidth consumed by OneDrive, you can visit the following link over here. But in general, we highly recommend that you rely on files on demand because it's really going to alleviate a lot of the bandwidth concerns that you might have when both deploying OneDrive and operating OneDrive on an ongoing basis. Additionally, there's a number of QoS policies at both OS level and network level that you can use to appropriately prioritize OneDrive traffic relative to other traffic, or you can also employ sets of throughput limiting controls that we provide in OneDrive to have fine-grained control over both upload and download throughput. I'm now going to hand it over to Andy, who is going to cover some specific scenarios on how to deal with them when you run sync client in your organizations.
Thanks, Andre. All right, let's talk about forks. So a number of you talked to me this week about moving data from an on-premises file share or file server into OneDrive, moving an H drive into OneDrive and possibly remapping that. One of the things you want to worry about, especially if you're doing this manually, is file forking. And so this is really when one file becomes two. And that's something that we're doing going back to Andre's previous point. Data protection is paramount. The best way for us to lose you all as customers is to mess with your data. And so we always want to make sure that no matter what we do, if we can't figure out what the right order of operations was and the right file is to represent on your box, we just have two of them. And generally this happens when you have concurrent local changes and cloud changes. So for example, if you have people that work on a plane, or they commute to work on a bus or a train or somewhere that has poor network connection, they're going to run into possibly this situation. So let's walk through an example, and that will help you to be able to understand what's actually going on here. So let's assume you have a OneDrive for Business or a SharePoint team site. It applies similarly to that. And you have a file there, and that file is myfile.txt, and its contents are ABC. And you've synced that locally on the bottom to the similar myfile.txt, its contents are ABC. Let's assume you go offline, you get on a plane, and while you're working on that file, somebody else works on it on the server. They change it to DEF on the server, and you, while you're working on the plane, change it to GHI. So very straightforward, that's fine. Both of those have happened, and nothing has changed yet. But you get off your plane, you sync back up, and we try and figure out, okay, what happened, and what do I actually put down on your local box? How do I represent this file? So what will happen is we'll take that file that you have locally, again, going back to what Andre had said, we make the server the master. If something's up there, it is the correct version. So we take your file, move it over, and we rename it. You've seen those renames probably with parentheses 1, or if somebody's machine is in a really bad state, their machine name 1, machine name 2 on that, appended to that file. And so we will create those duplicate files and then also download the canonical copy, which then retains the original name. And so the goal here is that we're making the statement that canonical copy, that's what's on the server. The one with the additional name was your change locally, and we couldn't merge that appropriately. So if you run into this, that's almost always the case. The best thing to look for is, are people working on the same file at the same time? Are people doing large amounts of work in a non-networked environment, and then they come back on with a large amount of changes? Note that I don't have this in the animation, but the next step of this scenario would be that myfile-computer1 would sync back up to OneDrive, and so it would actually be represented on the server, and the data would be present there. This happens less frequently with Office files, because if you open an Office file, as a number of you have, it's continually syncing, and it locks various portions of that Office file, not the whole file. And so the reason that you can do co-auth and other functionality within Office is because we've built that protocol to be resilient to this kind of an issue. And as I called out earlier, pre-existing data is a primary cause here. If you run into an issue where you have to reset a OneDrive, or you have to clear your local state, and you then have the populated OneDrive from your previous run of it locally, and then you connect it back up with the service, what we're trying to do is we figure out all the files you have locally, all the files that are on the cloud, and then we try to match them up by hash of the file and by location, and make sure that what's on the cloud is what's on the server, and again, or what's on your machine. And again, if we can't match those up, we fork them to prevent data loss. We do not want to overwrite your data unintentionally. All right, and then processing changes. I'm sure every single one of you have seen this, and I'm sure each of you has a customer that's run into this. To give you some background as to why this happens, processing changes is really OneDrive's statement of something happened, and I'm trying to figure out what happened. This is going to happen first if you have lots of frequent changes. So if you have a file that you're actively editing, or if you sync something like a PST that Outlook writes to all the time, every single time that that file is written to, we get a signal. And when we get that signal, we then turn around and look and try and figure out what happened, and then try and figure out what happened on the service and match that up. So lots of frequent local changes will very clearly get you into processing changes. If you have a locked file, we're continually trying to get a hold of that file and be able to sync it up again, because we want your data as quickly as possible up to the service so it's backed up and safe. That will run into this situation. We've talked a number of times this week about Team Site Automount. That was a lot of feedback from you last year at Ignite. We went and implemented that this year. And what that will do is it will create a team site on all of your customers' machines that is common across all of them. And that's great, very powerful feature. The downside to it is if you have thousands of people syncing that site and a lot of them are active, every time a change happens there, we push a notification to the sync clients that are syncing that site, and we say, hey, come back and get what changed. And so if you have 1,000 people actively editing that site, one change is going to fan out to everybody. If somebody else changes it, one change is going to fan out to everybody. Each of those cases will turn into processing changes. And then team sites also have some specific functionality built into them that many of you use, which is very powerful, but also changes the file itself. So if you were to upload a Word document and you have a workflow on that to stamp it with something or update the data within that document, that change that the service does is going to come back down to the client, and that will cause processing changes, as will some things like property demotion and property promotion. If you have a required field on a team site and we upload a document and that required field is pushed back into the document, that will again cause this as well. All right, now I'm going to hand over to Adam for the last two of our kind of deep dive topics.
Cool, thanks, Andy. Now we're going to talk about something called a sync storm. So this happens when you've got a ton of files in a shared library, maybe like a big team site, and you have lots of devices that are syncing those files. And then you have some kind of global library event that causes all the files in that library to change. Then you get a sync storm. And what happens is all the devices start syncing those files, and your network traffic spikes, CPU spikes on the farm until they finish syncing. The main example that we see of a global library change is a list schema change. And Andy kind of talked about this a bit, but that's if you add or delete a column in your SharePoint library. What happens is we have code in the service that runs and takes the value of that new column and sticks it in the files, every single file. And it's a super powerful feature, but it causes all the files to change. The other thing is, of course, any kind of bulk onboarding. So if you take some files, a lot of files that you're migrating to a team site that people are already syncing, that can cause that data to fan out and cause the sync storm. Now, many of you are probably already thinking of ways that we could optimize this situation, and of course, we have as well. One of the biggest tools we have in our tool belt is files on demand. And so, if you're using files on demand, for the most part, the files are not actually synced on the device. And so when all the files change, we don't have to sync them all to those devices, only the ones that are actually hydrated on the device. So that's like a great mitigation for this problem. And now that, how many of you knew that we were rolling out Mac files on demand now? All right, awesome, cool. So that, for those of you who have a lot of Macs in your company, now this, becomes even better mitigation. The other thing is, but even when you have files on demand, there are cases that you have, big files that are actually synced on the device, maybe a big PowerPoint or whatever. And in those cases, we still have to sync the entire file down there. So we're actually looking at more optimized sync algorithms, so we can actually detect the properties that changed in the service and just pull those properties down to the file. Now, this stuff is all still in development, but we think that it's part of the full solution ultimately. Now, all these things that we do to try to solve these problems that we detect like sync storms, we have hypotheses on how to solve them, but really the only way we can detect if we've truly solved them is via our telemetry. So now I'm going to go talk about our telemetry, and I'm going to shine a light on how we go about detecting and remediating issues in the sync client. In general, in any service, the way that you get quality to get high is you have to drive down mean time to detection and mean time to recovery. That is the name of the game. And so if you think about it, let's say we could detect every single issue that we created in an inner ring and like a small set of test users, and we could fix that issue in those set of test users, well, that would mean none of the issues actually get out to the larger audience. And that's what we try to do. In addition, we try to detect in the wild, if we have a dependent service that goes down, we have alerts that actually monitor that, fire the alert, and we send it to that service so that our partners can basically fix the problem and minimize the impact. All right, so now I'm going to talk a little bit about when we actually try to detect issues, we have two main approaches. One is we have this periodic auditor, and this thing runs every 1 to 3 days, and essentially what it does is it does a full metadata scan of the local file system, a full metadata scan of the cloud, and we compare the two. And if they don't match, we tell ourselves that, and that's a problem. And we try, this is actually one of the most important signals we have in the client, and we aim for 100% matching convergence. So that's one signal. The other signal we have is real-time monitoring, and this is like on transactional things. Hey, if I can't sign in, we get an error and we monitor those errors. If I try to upload a file that fails, we understand that at the moment that it happens. So now I'll talk about our release strategy. When we do our releasing, we use a ring-based approach. And so our smallest ring is just our team. And after that, it goes to all of Microsoft. After that, it goes to our insider population, which is a few million. And after that, it goes to production. And then finally, it goes to the slowest ring, the enterprise slow ring. And so using this ring-based approach, what we do is all these quality signals that I talked about earlier, we slice them by the rings. And so when it goes in the first ring, we make sure none of those signals go down. And if it's OK, it makes it to the second ring. If at any point the signals look bad, that build doesn't go to the next ring. And so this is how we manage the binaries. In addition, some of you probably have asked, I know at the booths, when is KFM coming, or when is this sort of variant of we have a mass delete feature that's rolling out. We have a lot of features that are rolling out, and when we say they're rolling out, we literally mean they're on in one of these rings, but they haven't made it out to all of the rings. And so again, the same kind of approach. We turn on a ramp, make sure everything's good. If it isn't, we can quickly turn that ramp off and stop any kind of damage, and then we try to fix it and try again. And what's cool about the ramps is we can turn a ramp off, and the build can keep on rolling. So it gives us a lot of flexibility to have high velocity without making quality suffer. So we've got a ton of success stories using this approach. I wanted to quickly highlight a couple. One is in Files on Demand. So if you look in Finder and look at pictures or in Explorer, we download those thumbnails on demand. And so one of the things we do is we're going after the quality on that. We want to get it to 3 nines, which is 99.9% reliable. And so when we were looking at this, we found a couple of HTTP errors that our service did not emit directly. And it actually accounted for 18% of all the errors for thumbnail download. And so we were like, whoa, this is kind of a mystery. What do we do about it? We dug into the telemetry, got logs, and it turned out to be only 2 tenants that had misconfigured proxies. And so it was failing the download. So we reached out to the tenants, they fixed the problem, and the result was now the users have a way better experience. And so that's an example where they probably wouldn't have figured that out on their own. I mean, they might have figured it out on their own, but they probably wouldn't have. And so us shining that light through our kind of vision helped everyone. So the other example is also with Files on Demand. When we first rolled it out, we wanted to work with the antivirus companies to make sure they updated their product so it was compatible. And the problem with antivirus and Files on Demand is if they don't know anything special, they'll just go scan your whole set of files, and they'll hydrate all the files when they're scanning them for viruses, which kind of ruins the whole feature. So we wanted to work with them and have them understand when a file is a placeholder so they could skip over that file for their scan. But there's so many antivirus companies out there and products out there, it was a daunting task. And so what we did is we added code to detect which antivirus software was running on the machines, and then we could sort by the top ones. And it turned out the top 10 antivirus products accounted for over 90% of all of our users. And so it was super helpful for us to focus on just those top 10, worked with those folks, and they updated their products, and we did all that before release, and we had a successful release. So My last point here is really a pitch to you all to say, please don't block our telemetry endpoints. Because this really, as I was saying, this is our lifeblood. This is how we prevent issues from cropping up. This is how we detect issues in the wild when they happen. This is how we keep the product good, but also this is how we make the product better. And so I listed a couple of the key domains there, but there's a link. Oh, cool, they actually expanded the link. There's a link in there that will give you a list of all the endpoints for O365. And yeah, please don't block them. So thanks so much for listening, everyone. And I don't know if we have time for questions. No. OK. Yeah, you guys can stop by afterwards. Yeah, go ahead. OK, quick one. We have 26 seconds. Yeah. Yep. Yep. At the moment, it's the full. Well, it actually depends. If it's an Office document, it actually is not the full file. But if it is not an Office document, at the moment, it is the full file. Although we are aware of that, non-optimization. Yeah.
When you're online and you make a change to a document, is that change being affected on the local file?
If you're online, what do you mean online? You're connected to the internet, but you're making a change to a local file?
Well, you just pull up the document and you make a change.
OK. If you pulled it up via a document that was synced and you make a change, what happens is it makes it on the local file and it syncs it up to the cloud. So both. Correct.
So, but if, because I have this question, hold on, we really couldn't figure it, but if the user opens the file from the OneDrive and makes a change again, where is that saved from?
It really depends. So if they're on the website and they open the file in the website and there's no local sync going on, it'll occur, it actually occurs in the website, it goes to the cloud, and then it gets synced down to whatever devices are syncing. If they double click on Explorer, say, and open the file locally, well then what'll happen is it actually, even that depends. If it's an Office document, we have optimizations, so the writes go straight to the cloud, and then they circle back to the local file, but to the, yeah. Yes, absolutely. Always to the cloud, yeah. As fast as possible, online, absolutely, yeah. Yep. All right, we can take other questions afterwards. Yeah, we'll just shut it down. Thanks so much.
Thank you, everyone.